All right, I think we're at time, so I will go ahead and get started here. Hopefully you are here for the location of things from A to X, Y, Z. And so the way I've actually organized this talk is around the alphabet. So behind each one of these letters is a different location theme. So since some of you may be beginners or new to location, there's a few of these introductory concepts. But I also do, toward the end, get into hosted geospatial database and some of the more complex things. So I got a few demos planned here as well. And if you see a letter and you happen to know what the topic is, feel free to shout it out, see if you're right. You can keep score for yourselves. But I'm going to start with D because I'm not necessarily going to go in alphabetical order. But my name is Jayson DeLancey, so the D is me. That is my Twitter handle to make the social media team happy. I am a developer evangelist. If you're not familiar with what a developer evangelist is or developer relations, that means I'm responsible for the things that you can find on developer.here.com. So if you were a software developer, you're trying to use our APIs, hopefully I can do something to help it make it a little bit easier, a little bit more approachable. Maybe that's a little tutorial, talk such as this, answer any questions you might have. If you find something you don't like, that is also what part of my role is to be an advocate for you. So if there's something you're looking for, something that's not clear, I take that feedback back and harass the engineering and product teams until we can get something resolved. So that was the D. So now on to A. Autonomous world. So this is sort of my personal interest. This is how I got into mapping. So if you think of autonomous cars, drones, robots, it's kind of a complex problem to solve, how to move about space and around things without bumping into them. I was in the industrial IoT space for a while with General Electric, and I also worked on a few projects with a hobbyist group here, Silicon Valley Robot Operating System group. Tried to make a entry into a NASA Centennial Challenge. So this was, again, taking a robot, trying to be able to navigate around the field, avoiding trees and squirrels and other things that might happen to come about while trying to pick up the equivalent of a rock in an 8-football field area. Certainly having a map or an understanding or a reference point of where things are help make the computations a little bit easier to get bearings and things like that. So that's where maps really come into play and part of my interest. Also under the category of A, I'm going to mention the app ID and app code a lot, and you'll see this through some of the demos. That's just the way we handle authentication, also an A word. So when you're making service requests, you have an account, and you'll need to be able to associate it with it. So on our developer portal, we do have free developer accounts, premium tier that gets you up to 250,000 transactions, and all you need is an app ID and app code, and when you include that in your request, that's how you authenticate and get access. H. So this is a message from my sponsor. Here Technologies is the company I work for. Not everyone's familiar with Here as a household name. Here is the open location platform company, enables people, enterprises, and cities to harness the power of locations. And so that's where I think of a mission as creating a digital representation of reality to radically improve the way everyone and everything lives, moves, and interacts. And that's kind of a very ambitious mission, of course. In the past, I used to make cartoons, and so I was in the computer graphics realm. But when you take a look at the real world and having a 3D representation and the types of things you can do with that, everything from augmented reality games to, again, robotics, it becomes kind of some very cool and interesting projects. By the numbers, just to give you a sense, again, if you're not familiar with the company, over 200 countries mapped. Some of these numbers may vary from when they were originally captured, but we actually have a pretty large organization with globally across the world, nearly 8,000 employees. Been making maps for 30 years under a couple of different names, branded as Here, I believe in 2014. In-car navigation is probably the way a lot of people may have come into contact with our maps. But to give you a sense that mapping is kind of a complex problem, we collect something like 28 terabytes of map data every day, and it's growing from that. I mean, while we're here in a building, it may seem like the building doesn't move much, tectonic plates willing, but maps do change, people change, businesses change. There are a lot of updates that happen every single day. We do have a fleet of cars. That is one of many ways in which we acquire data ourselves. It is our maps, it is our data that we provide through services. And so obviously getting 3D point cloud data, 700,000 different data points per car per second. So obviously that is a lot of data, a lot of churn in terms of how maps are made. Again, you may not recognize here, but you may recognize many of the businesses that we work with, traditionally a little focused on enterprise and developer use cases, as opposed to a consumer-facing product ourselves. So there you go. L, any guesses for what L is? Yeah, location. So where am I? Location. You are here on Earth. It's not very precise, but it's true. This is a picture from the NASA's Curiosity rover looking back at Earth back in 2014. But if we do want to get more precise, again, this is sort of a basic concept, but again, everyone knows latitude, longitude, or if you are good at math, longitude, latitude. So the order does matter in how you represent a place on the planet, as well as precision. So here's a few examples that if you just have one decimal point at the end of your values, you may know, okay, I'm in the state of California, somewhere around San Jose. But as you add additional decimal places, of course, you get a little bit more precise to know that, hey, we're sitting next to each other in the same room. Now that said, if you get back data that has that level of precision, it doesn't necessarily mean it's accurate, but it does mean it's precise. So you have to take that into consideration as you're looking at latitude, longitude, and what those values actually mean. Onto U, Universal Transverse Mercator. Really, I'm just using that as an example that despite what some people may think, the Earth is not flat. It is not a sphere either, so it's not a perfect circle. So you need to take into account different projections when you're measuring distance and how to get from place A to place B. Turns out over great distances, the Earth keeps literally getting in the way. And so you have to take that into account in calculations. And so that's where when a lot of people start with, oh, it's just latitude and longitude, I could just throw that in the database, that's easy. It gets very complex very quickly from there. It's not complicated, but it does get complex. So on to G. Any guesses for G? Oh, no, I'm going to surprise you on this one. Geocoders. So this is, of course, taking the real world, trying to get into a number representation, but we, in principle, are at 2161 North 1st Street in San Jose, California. So geocoding is really taking that real world address and coming up with geocoordinates. And again, new buildings are constructed, some buildings go away. So being able to have an up-to-date database where you can run these queries becomes pretty important. Reverse geocoding is really just the reverse, right? That's when you have a latitude and longitude and you're trying to figure out what's near that place. So just to give you an example of what this looks like, I'm gonna jump over to a shell. So I have two scripts here, just to give you an idea of what I'm doing. So I tend to program in Python or JavaScript, Java when I'm coerced. This is just to give a common denominator. I'm just setting up a little curl command. But this is what a request to our geocoder might look like. So you're hitting a certain endpoint, again, the app ID and app code for authentication. I use environment variables as a good practice as you move scripts around, of course, and also I don't want you to take mine. And then really it's just search text. So it is a fuzzy matching, but if you have a street address, you just put in that street address and then you can run it. And so what does that look like? You get back a fair amount of results, looking for my mouse, but what's interesting here is that some addresses are not always crystal clear. Like if you're in a large building and you're looking for a particular apartment, right, this is a large complex, so there's a little bit of interpolation that's being guessed to get the precise address of certain places. But generally, you have a map view, so like if you're putting a pin on a map, you might want to know where this building is. If you're trying to drive to this place, you probably don't want to drive to this room. So that's why there's also a navigation position. So there's a little bit of a differences in terms of that results. I will save some time for questions toward the end so that we can come back to that, anything that you might be wondering about that. And just to give you an idea, so here's the reverse of that. So it's again having the app ID and app code, but also a set of coordinates as well as a search radius. Because sometimes you might be at a point and you're just looking for any addresses that are nearby. And similarly, you get back a set of results giving you some addresses of things that were within 100 meters of this space. So that's the basics of in geocoding. Any guesses for B? Okay, I'm cheating. This is batch geocoding. So this is really about an asynchronous runtime of batch geocoding jobs. So that if you have automation, so it's not just looking up a single address, but maybe you have a whole database of addresses and you need to validate and handle customer data, that type of thing. So this is just an efficient way for doing the queries so that you can send a batch of jobs, maybe 100 at a time or whatever the case may be, and then get back a job ID and then check and get your results later. Autocomplete Geo Coder, this is the thing you might experience if you were typing in an address, that as you're adding additional characters, you're getting a little bit of a fuzzy response and helping you try to identify the place that you're looking for. And this also works with a few other types of searches for locations and points of interest and things like that. Speaking of which, P, so places, points of interest. So as you're trying to search and discover, we do maintain a comprehensive and flexible places search system. So if you're looking for Empire State Building, you're looking for the Eiffel Tower, you're looking for a park, as well as individual street addresses, we do maintain a database of that and certain data, so landmarks, as well as things that happen to be in the vicinity of the place that you're interested in. We also have the option to search by categories. So what does that look like? So if I jump over to places, so again, it's a slightly different endpoint being queried, but again, the app ID and app code pattern. You start from some position, so it's again searching for places within a particular vicinity. So if I'm looking for fills because I need a fix this afternoon, somewhere around that coordinate, I can run a query like this. And of course, I can filter or do whatever type of processing I want on this result set. So if I'm building an application and I want people to be able to find something that fills, which could be a little bit fuzzy in terms of the things that might match, I can actually curate this list of results as part of the experience I'm trying to give to people that are consuming my application or whatever I might be trying to build. Similarly, each of those comes with some additional details. So if you're trying to get more details about a place, you can actually find that in the database there are things like email addresses and websites and contact information, as well as more details about the road and hours and those types of data points. And that comes through a large network we have of partners and people that help us with maintaining that information. N. Okay, now I'm kind of cheating. So GPS, originally under the umbrella of Navstar, put a bunch of satellites in the sky, a lot of space junk. But in order to, of course, figure out where you are on the globe, you need to be able to triangulate with more than one of them. So also, and what happens if you have no GPS signal? So for example, I don't know about anyone else in this room, but my MacBook does not have a GPS in it. So you may be wondering how exactly you get locations. So I'm going to show a little bit of a demo here. So if I look at this HTML document, very simple, obviously not doing a whole lot. This is just using the geolocation spec of HTML5. So if you write some JavaScript that you're trying to get the current position and just throw it out to a log file, for instance, right? Nothing too particularly fancy. But let's say I'm going to go ahead and serve this and load it up in Firefox. I get a prompt whether or not to allow my location, right? And as soon as I say yes, there's my mouse, it'll actually, the browser will negotiate, go ahead and find a position, and here it is in my logs. So as I can see, it actually came back with a latitude and longitude, and it thinks it's as accurate as my fingernail. You might get back different responses to where you are, and it may not always be accurate. And you may be wondering why that happens, because it's not using GPS. So what is it using? So if you go into About Config of Firefox, you can actually see that there are some particular variables, such as the Geo Wi-Fi URI. So if you were actually to change this, and let's say I'm kind of curious about this one. So I'm going to go into run HTTP echo server. So I'm just going to go ahead and run that to listen for events. And I'm going to go ahead and say, let's put in localhost 3000 instead. Now, when I go back to my page, I'm going to go try ahead and load it. It says, yes, I'm going to share my location. I'm not going to actually get back any results there, but I can actually look at what the browser is sending to my server, right? So I look at this and I see what the computer in the browser is actually doing here is it's actually looking for a radio map, saying every Wi-Fi within range, let me get that. And if you find enough of them, including the signal strength, I can roughly triangulate where you are, where your position is. If I were to take this request, and I'm going to go ahead and cancel out of these servers, but if I go and look at a payload, I do a little bit of scrubbing with it, I can call a positioning service like this one. So it's again, this is one of ours that you have an endpoint you're trying to locate with app ID, app code, and I'm reading in this payload, that JSON response. And if I do that, I get back position. So here's the latitude and longitude of what our positioning API thinks as terms of where I am physically located. You also get back, an accuracy, so you can sort of start accounting for if you have a mobile use case, a car, a robot, a drone, how accurate do we think we are, and that will vary depending on the strength of the radio signals in the immediate vicinity. W. Let's see what W is. So W is, a lot of people, like I said, you may not be familiar with our brand, but we do actually have one consumer application I can kind of point to, which is Here We Go. So this is not unlike you've probably seen in many other places. It's just the URL is wegohere.com. But it is a different presentation. It is our style of map and the places of interest that we've rendered. There are different types of view, including layering on traffic, transit, satellite views, terrain views. And what I often also like to do is being able to go and look at the latitude and longitude if I'm trying to handle a bunch of different locations. It's another convenient tool to get a very quick rendered image of where things are. And of course, this allows you to search the database of places and things like that, as well as get an app for mobile if you so choose. But that's just one thing that some people are curious, that how do you use a lot of these services and APIs? What is something you can build? This is probably a more complex example of something. You can use subsets of this and curate your own presentation. That's what our APIs are for. But M, this is a pretty easy one. We make maps. That's all I got to say about M. R, what's R? R is routing. So we do have a lot of algorithms that are really about how do you get from A to B, but also not just A to B. It also depends on whether you're in a car, whether you're walking, whether you're on a bicycle, whether you're in trucks, and what you're trying to do. So we do provide a lot of options in terms of preferences. So when you're running a query for the routing service, you might be trying to avoid toll roads, or you might be looking to avoid highways. You might need to take a ferry to get across water. That's actually part of the responses. You might not be allowed to go through tunnels because you're driving a truck. You might actually be an off-road enthusiast, so you're actually seeking out unpaved roads. That is also okay. HOV, the fastest route, shortest route. It also may be the case that you're trying to optimize for fuel efficiency. So being able to see the slope of the terrain and things like that could be pretty appealing in terms of what type of app you're trying to use or create for someone. And of course, there are physical and legal restrictions as well. So like certain trucks can't drive hazardous waste on certain roads. And so all those types of routing scenarios are taken into account. If you're developing an application, it's this problem of, are you trying to solve just the base case, the one that 80% of people are used to, or do you have something that will handle any place on the globe and a lot of those different complex routing scenarios? So having a complete solution is a little bit more to the focus of some of these APIs. We also have a matrix routing. This is a little bit more interesting when you start thinking about the complexity of solving these types of problems. So again, this is really your traditional traveling salesman problem. You're trying to get to a bunch of different places in a particular order and being able to tune and control some of the cost factors of which places you should hit first and in which order, or which ones are unreachable within a particular delivery window. And so where you might see this a lot Has anyone ridden one of the scooters or used the ride-sharing application, those types of problems, right? So being able to efficiently work with an entire fleet of things across a city to plan out, next to business hours and when things close, that's the type of thing you might use with matrix routing. There is also a type of routing called isoline routing. And this one can be pretty interesting. If you have a particular point of interest and you're just curious, how far can I go, either by time or distance within a particular range? So certainly for a lot of public service use cases, things like that, you might be interested in saying, hey, I'm looking for a house that's within 30 minutes of where I work. And so we actually have a demonstration on how to do that. But you can also do a lot of ways of tuning how exactly that is calculated, the speed, ascent, descent. There's a lot of these types of parameters in the routing query that you can make. It's the idea of interactive maps. This is probably what you've experienced on the web. Again, some people call it slippy maps. The idea that you have a quality map that you're able to move around and zoom in, zoom out, pan, search for certain places. I don't think there's anything particularly surprising about that. But where it does get interesting is, again, is when you're trying to think of that global scale of quality. So these are 2 image tiles, and there are parameters that you can use to make queries that are actually about this little disputed border area. So if you see that little box over there, it's actually kind of an interesting story historically that there is actually not a defined border there. So depending on which country you live in South America or who you associate with, you may have different opinions on where that border should or should not be. And the story there, of course, is there's remnants of a glacier that just hasn't been sorted out yet where exactly the border should be, becoming less and less a problem, though, as time goes on. There are other variations of image tiles. So again, just to give you a sense of the types of applications you can build, if you're trying to represent a heat map of different points of interest, the colors can be used to express how dense particular sort of information from your data set is. There are variations where some people want to see the picture-in-picture and different ways of customizing exactly how information is presented. Here's another example. This is actually showing the height at various points around this area, just around Zurich. So if you're going out for a bicycle ride or something like that, and you don't want to have a big hill, or if you're just going for a walk, you can start planning things strategically that way to make sure that you're going uphill both ways. Or you might have other information that you want to layer. So we also provide options so that you can actually query to get zones based on census or zip codes, information like that, so that you can slice and dice and figure out exactly what is in a particular region as you're making queries. And of course, you might want to customize the look and feel of maps. We offer lots and lots of different variations, from different night views that might make more sense in particular displays or particular work environments, or more playful ones like this one, which is the DreamWorks theme that we offer, which is interesting to me since I used to work there too. T. T is for traffic, which I do not like. So you can, of course, with any of these images, you can get the traffic tiles as well, both real-time and historical. So this is actually one of the demos I had built, and I can pull up if you're interested, looking at my commute. So I know where I start from point A, I know where I need to end up at work, what time of day should I leave on any given day, and being able to run queries and an analysis like that based on this historical traffic information is something you can do from the traffic service, including the real-time speed of traffic. How that all works is actually pretty interesting in terms of GPS and FM signals, but you can also locate where incidents are and things that you might want to avoid. F. So this gets a little bit more complex in terms of some of the services that are available in fleet telematics. And so this is also referred to sometimes as platform extension. So this is about really bringing in your own data. So yes, you want a representation of the world, where places are, how to work with it, but now you also might have custom locations. So like my house is a custom location for me, and I might have a small data set, but if you are working on an app and you have a user community that might be submitting their own custom locations, this might be a tool that you can use to sort of manage and monitor that. Custom routes, so this is again, maybe you know where there are road closures or there's just a street you really don't like because it goes due west at sunset. So you can actually provide custom route information, ways to feed and manipulate how to get around from place to place. Geofencing is another term you might come into contact with. This is basically API that allows you to say, within this particular area, I want to be able to go in or avoid with assets. So this is, again, let's say you're in parole or something, and you're building an app for people who aren't allowed to leave a particular city. It's a weird example, but you might be working on something that's saying, yeah, here's an asset, I'm loaning it from my library, but everybody should be within the city limits or something of that sort. So there's different geofencing types of applications where you want to know when you're getting close to home to turn the lights on, right? Those are your IoT type of applications. And waypoint sequences is, again, being able to actually provide data that feeds into those algorithms about what order, that traveling salesman problem, what order should you stop at places, and maybe there are certain conditions, like what hours. Like you can only stop and deliver a package during 10 and 11 a.m. for this particular waypoint, and that'll be seeded into your preferences for planning out a series of stops. E, enterprise grade. So there are a lot of enterprises that use a lot of these services. So again, I've sort of touched on transport and logistics, utilities, government, insurance, retail, web and internet. So lots of different use cases. And then C is for connectivity. So again, still under the custom routes, fleet connectivity, being able to know where you are, where you're going, and some of those sort of customizations. V is for venues and indoor positioning. So here's another scenario where if you're planning to build an application, and there's not a whole lot of these out there, that you're not only just routing from A to B, but you're also trying to get inside of B. There are, let's see, that's the postal boundaries example. Yeah, if we just go to venues.here.com, you can start exploring some of scroll down here, you can go and start looking at some of these indoor maps, which can be kind of interesting to explore around. So we're in San Jose, so if you wanted to go and take a look at, let's say, the airport, if you're making plans, I just found out there is a Java bot, so a coffee making robot, which of course I want to plan which terminal should I go to and how do I go about getting to that place. There's my mouse. So you can actually go inside and start exploring maps of indoor venues and maybe include that as part of planning the rest of your itinerary in an application. So again, there's lots of different ways of using these APIs, but there's a lot of data around indoor as well as outdoor map scenarios. And so that's what indoor positioning is really all about. Couple of these, we do have SDK in JavaScript. So I'll pull up some of these samples as well, and we can take a look at what some of the code looks like for working with the JavaScript API in a moment. But we also have, for K, Android SDKs as well, if you're working in for an Android platform, or if you're working in iOS. So a lot of different mobile SDKs that you can use. I do want to make a mention of open source. We recently have started open sourcing a few projects that can be particularly interesting. This one that was most recent is called Tin Terrain. So this gives you a little bit of insight into how you process some of this data. So basically, it's the idea that you have geotiff data that is showing an aerial view of a place. So if you have a drone that's collecting data, satellite imagery, but you want to be able to store that efficiently, these files grow pretty large pretty quickly. So this is really an open source project that helps you process that data to create 3D meshes in the shape of tiles. Because again, to make a request performant when rendering out a location, being able to tile it as you pan and zoom around. And so here is a representation on the client that when you take that 3D mesh and then you start taking those tiles back together, it's an efficient pipeline for taking that aerial photography on one end and then being able to store it and serve it out as far as a presentation later. So we do have a GitHub organization called Here Maps where you can find projects like this. There's a few others related to flat data, working with binary data, and a few projects that are part of sort of this pipeline of how do you deal with large-scale imagery and extracting information and data out of it. So that's something that's worth taking a peek at if you're interested in what some of the open source projects are. And that brings us to XYZ. So XYZ is a new geospatial database that you can interact with. And there are some tutorials and things out there about how to work with GeoJSON. How many people are familiar with GeoJSON as a format? Is anyone familiar with it at all? So I'm gonna go ahead and pull up some examples here. So here is GeoJSON for airports. So as you might expect from the name, it is, of course, JSON data, but it is very specifically the semantics around geographic locations. And usually that is divided up into a couple of primitive geometry shapes. So of course you have coordinates, and so if you remember back from L, I was saying longitude being a little bit, the order matters. So for GeoJSON, it tends to want longitude, latitude, and that's true of a lot of maybe half of the geospatial libraries you'll find. The other half will use latitude, longitude in the other order. So being able to work with this type of data and scrubbing it with whatever programming languages you prefer becomes very handy. So hence I do a lot of Python manipulation of GeoJSON. But in this case, so you have coordinates, but you also have points. You can just think of that as a dot. Line strings, of course, is just a line, and a polygon is some sort of shape. Based on those three primitives, it just scales up very quickly. So multi, you might see something like a multi-point or a multi-line string. As you can guess, that's just an array. So within JSON, it's an array of coordinates, just to help compress the file a little bit more when you're talking about really large data sets. And then there's also this notion of a feature. So a feature is sort of this collection of geometry plus properties. So that's just your standard dictionary of facts about places. So if I were to take this GeoJSON for airports, I can jump over. Here, XYZ. There's a couple of different aspects to it, and one is the Studio Designer. This is a good way of rendering out a map with some of the customizations that you might be interested in. So if I were to take this GeoJSON, which I did just because it takes a little bit of time to upload, you actually, this tool gives you a way of taking the GeoJSON, visualizing all of the properties, as well as how it renders out on a map. And so what this tool is giving me is some options for configuring the look and feel. So like if I jump over here to San Jose, and this is just a publicly available set of airport information. You can look at what type of information you have, the name, an abbreviation, maybe a link to a Wikipedia page. But this is data that I can manipulate and extend and then customize the view and presentation of it in Studio. So like if I come in here, maybe I don't want blue, but I want red. I can make some of these sort of customizations in terms of the appearance. I can publish this and literally just copy and embed code, and then I can go over to my HTML document and just paste it in. obviously I need a few other tags there, but that's basically the idea. Very quickly I can go from taking a GeoJSON file, creating a visualization, customizing the look and feel, and then sharing it out on a web page I might have. Let's see. So there is a CLI that helps work with this a little bit. So again, I don't want to do the actual upload, but when processing the GeoJSON file, there are libraries in different languages. This happens to be written in JavaScript. But you get a space that's yours to store data, manipulate it, and do certain things like tagging to slice and dice that data. So I could take that GeoJSON of all of the airports of the world and create a slice that just says, maybe I'm only interested in certain airports within the United States, or whatever my data set happens to be. In this case, I actually just have a quick screen grab of all of the trees in Amsterdam, which actually is an interesting data set. So let's take a look at that. I already did Studio. All right, so if I come back to, actually I think I have it up here in Firefox. So this is an interesting visualization here, which as we get in, I'm gonna show a little bit about how this is created. But the basic idea here is this is actually trying to render out where all of let's do the trees. So, here's 307 trees within this space. So if I'm trying to do an analysis of, well, how many trees are in what particular neighborhoods relative to solar installations in a particular city, once you have some of these data sets, you can start layering them in and creating some very customized presentations. So this is taking that GeoJSON data, storing it in a geospatial database known as XYZ, and then coming back and using something called Tangrams, which is a WebGL-based rendering engine. So to give you an idea what that looks like. So it's a very basic HTML file, a little bit of styling, and a couple of layers, but it's pulling in Tangram and leaflet layer to make this drawing. And then within the scene YAML file, pulling in a few dependencies, but fundamentally, for each of these layers, it is referencing an endpoint where XYZ can serve based on the parameters, so actually Z, X, Y in this particular case, based on the data set to fetch tiles, and that's how they're all then layered in. It's as a service, geospatial database as a service right now. It is in our freemium tier. So it is a place to store and work with a limited set of, I think there's 10 spaces you can use, for instance. So that's the basic idea of, so some of this data, so like here's the heat map of JSON. So as you can see, these feature collections can get quite large in terms of the number of coordinates and the type of data. So that's where the geospatial database really comes into play, is that there are a lot of processing is done on these files to try to deal with the fact that there's a large amount of complexity, especially if you look at it over the entire planet, when you're trying to then just scope down the search to a particular bounding box and being able to slice the data to only certain tag data within that space. So maybe I'm only looking, that's why this rendering is actually kind of difficult to do, because again, we're talking about every single tree within a city, every solar panel within a city, and being able to find and calculate what the power generation and consumption is, sort of the carbon footprint in certain areas based on where things are being selected. So one of the things that's kind of interesting about that particular example is that there is a tutorial that actually walks through the entire process of creating that system by storing it in an XYZ space and running those queries. So this demo is something that you can go ahead and use within the freemium tier to store data, and it may not be trees in Amsterdam that interest you, But using that if you're trying to solve a local problem in San Jose or wherever it is you may be interested in working on, gives you some tools to be able to upload and manage and manipulate that data. See, there is another example here. So earthquakes is another example. If I were to run here XYZ list, I want to show this earthquake data. So I'm just using the command line tool to take a look at this data. It should throw it up in a web browser for me. Actually, this is kind of interesting as well. So if you're looking at this earthquake data set, this is actually just printing out sampling on the command line so that if you're trying to do some processing of the GeoJSON, the CLI helps you do some of those things. But that's not what I wanted to do. Okay, so this is an example. So this is another tool that's part of this. It's called Geo Json Tools. So this is actually one that you can find more details of, but it gives you a little GeoJSON editor. It's a little bit easier to look at than VI, probably for normal people. But you can sort of look through and get a sense of what the GeoJSON data is. You can load new data into the editor and make tweaks and adjustments and get an immediate visualization of it. So if I go back actually to this example, this one, this is my earthquakes. And get a quick rendering of all of the earthquakes that happen to have happened over a particular, I think it's a 30-day time span. And so, of course, you can, when you start looking at data in aggregate, being in GeoJSON, being able to scrub the data, make changes, filter, tag it, and then run queries, get this sort of visualization. This gives you the ability to sort of start looking for patterns like, hey, might be something interesting about this string of earthquakes that happen in a nice clean line. And so that's another way of taking a peek and looking at your data, doing some exploration, and making use of some of these tools in XYZ. So I'm going to pull up one more example here, just to give you a sense as well of some of the libraries in Python. So if you go to developerhere.com, go into our blog, this example right here. So one problem you may find yourself getting into is how to work with large data sets of GeoJSON and how to manipulate them. So as I said, I'm a little bit more partial to Python, but this is actually an example of some of the libraries you can use, GeoJSON, Shapely. I don't know, anyone here Python developers, more JavaScript developers, Golang, Java, .NET, okay. But for little quick and dirty tasks, Python can be pretty handy. So one thing you might have noticed from those primitives I was discussing that yes, you can draw lines, points, as well as polygons, but not really circles. And circles get to be a little bit complex because of that projection problem. So again, I can show you a very nice circle on the equator, but other parts of the globe become a little bit more complex. So there's actually an example here where this library helps you generate basically a multi-sided polygon that looks roughly like a circle. And then you can render that out. So that was an example of Null Island rendered at latitude, longitude, 0, 0. There's not actually any land there, but it is a very common thing to do. Is to start with zeros. Gives you a little bit of an idea. So I talked a little bit about the CLI and how that helps you do some things like validation, as well as doing some of the tagging. So that whole rendering in that tutorial goes through the process of loading GeoJSON file, processing it. Actually is a JavaScript example of how to go and extract the neighborhoods and merge it with other data sets to create another subset of GeoJSON data, as well as Studio, where you can do some of those customizations. So like I showed the airport, but I could also bring in this earthquake data directly in Studio as well, and then start doing things. Like here, I think I wanted to render out earthquakes in green, and I was kind of curious about the magnitude and being able to style and make changes to it. So like even in this layer, I can make changes to it. I can add additional layers or customizations. So like even if I wanted to make it look different, you know, I can use different levels of detail, different map layers, or what I use for the base maps. And what you see here is also the push that, of course, there are the here detailed maps that you can use, minus a lot of the complexity of labels, so that you can bring in your own points of interest. So like if you are only interested in airplanes, but not parks, or if you're interested in parks, but not airports, you can make those sort of customizations to tell and customize exactly the type of application it is you're building. Maybe you only want electronic charging stations because you're trying to build an app for routing in a particular use case. Here's another sample of some of the tutorials and things that have been done with XYZ. So if you go to codelabshere.xyz, you can find the instructions for how to create some of these. So the Madrid urban air quality, what's interesting about that one is it's using the geospatial database to run queries over time. So again, this is about taking that large GeoJSON file and then tagging it based on a timestamp, and then presenting it out in a rendered image that shows you here are the air quality CO2 emissions for a particular day, and then cycling through multiple days so you can see changes over time. Or as I said, the solar installation, as well as trees in Amsterdam is another one of the demos. I believe this one is the earthquake data. So again, you can actually get a step-by-step instructions on how to use some of these libraries. So this one up here is also using Leaflet, so a few open source libraries and different ways of rendering them. This one using 3D renders of the globe. This is actually pulling a live feed of airline traffic so that you can render on a globe the flight path of different airplanes, which is kind of an interesting use case. So let's see if that one still is up and running here. My mouse keeps disappearing here. So global flight tracker. If you go through, I think we have a demonstration here. So again, this is the idea that you might pull some of the data from some of our APIs, but there are also other open sources of data that may be of interest to you and maybe nobody has used in building an application, so then it becomes this mashup, right? It's the taking the data of a map and presenting other information together to create an interesting story. So like if I were interested in San Francisco, maybe I could kind of come in here and start seeing what's going on today. I don't know, is anyone flying out today? So I may not be here watching you, but you never know. So again, you can kind of get a sense of the types of rendering, the types of data, the types of queries you might make through, if I start looking at some of the other airports as well, see what's going on. There's a few over there. That one looked a little bit busier. that gives you kind of an idea of the types of things that you can do with some of these APIs and data sets. Q, the last letter, is of course for questions. So we do have a lot more information on developerhere.com about what some of these services are. You can go through, I can pull up the JavaScript examples as well if you're more interested in those. Here XYZ, that's the newest thing in beta. So there's a lot more information about there. And of course, I am Jayson DeLancey. If you have questions, feel free to reach out to me directly as well. Yeah.